Hi, good evening, everyone. Welcome to our Solar Expert series. And the concept behind this is for us to really get first-hand, in-depth knowledge about the current trends in the solar industry. As we informed you earlier, this is a continuing education we like the talent to have. So going forward, we'll be bringing or we'll be creating this platform so that you can interact with experienced engineers and other solar leaders in the industry so that you can learn from them. So today we have a very, very experienced engineer in the form of Cyprian Okolo. He's the technical sales advisor, for West Africa for Fronius International. I've actually worked with him and alongside him before. He's a very great engineer with in-depth knowledge, and today he's going to be bringing us a presentation about the Fronius hybrid inverter. So please pay attention. If you have questions, you can put them up in the chat. I will be taking a short Q&A at the end of his presentation. So it's with great pleasure I present Cyprian Okolo. Cyprian.
Yeah, thanks a lot for the introduction. It's indeed a privilege and also a pleasure to be amidst great minds here to, of course, rub minds together, of course. From my end, I will be making hopefully a brief presentation. It's going to be say 45 minutes. It's supposed to be an introductory presentation, but then I decided to adapt it to a more detailed presentation, and that's why we have what you now have on your screen as a title, which is the Fronius Gen 24 Plus installation and commissioning. So I will be breaking things down and then giving you much more information with regards the Fronius hybrid inverter. It is actually codenamed Gen 24 Plus because of our vision of achieving full dependency on renewable energy sources, that is 24 hours. So that's why we actually named that inverter Gen 24 Plus inverter, with believing that with it we can actually achieve total dependency on renewable energy sources for 24 hours, of course, and beyond. Great. So having said that, I will go ahead to introduce us to the inverter in question. So if you don't mind, I would like to exit the video so that I can concentrate on the slides. So the Gen 24 inverter is actually a uniquely versatile inverter in that it provides very wonderful solutions, be it storage, EV charging, that is electric vehicle charging, energy supply at home, and of course, energy management. And then it can also be used for heating and cooling. And these are all separate topics on their own. And in this presentation, I'll try to see how I can give you all the necessary information that covers all these solutions that are achievable with the Gen 24 inverter. Okay, so like I said, I've adapted the presentation to deal with installation and commissioning. So we'll go through the installation, cabling, data communication, initial commissioning, Fronius, Gen 24 compatibilities, and then maintenance. And then afterwards, we're going to have a brief period of questions and answers. Great. So to start with, I want to believe that you can all hear me loud and clear, right?
Sure, engineer.
Great. So let's continue. So to start with, just to give you a brief characteristic of the inverter. So we basically have single phase and three-phase inverters. So they are named generically the primos. The primos are the single-phase inverters, and then the CIMOs are the three-phase inverters. So for the single-phase inverters, we have them in power classes ranging from 3 to 6 kilowatts. They all have 2 MPPTs. The first MPPT has an ampacity of 22 amps, while the second has an ampacity of 20 amps, while the battery input has 22 amps uh, current carrying capacity. So just like I said, specific points, I will try to give more information about this inverter. So here, I would like to point out that we have three major types of inverters. The first type, what we call, okay, so the first type, what we call the off-grid inverters, and then we have on-grid inverters, and then we have hybrid inverters. So off-grid inverters are the inverters most of us, I would say, used to. We basically call them inverter chargers because they can invert DC to AC and also charge a battery. And we now have, and they're basically used for off-grid applications, just like the name implies. And then we have on-grid inverters, or preferably called grid-tied inverters. Now, grid-tied inverters, they're not too common in sub-Saharan Africa, although they're kind of gaining, the installations of these kind of inverters and implementations gradually gaining traction. But then it's pretty much popular in regions where the grid is stable. And just like the name implies, it takes its control voltage from the AC load line. So with that, it now uses it to invert DC and then converts it to AC and then supplies the house. And then the third type, which is the hybrid. So this both grid forming, as in they are on-grid inverters, that's grid-tied inverters, and also can be connectable to the battery. Having said that, grid-tied inverters generically cannot charge a battery. You will have to connect it with an off-grid inverter or an inverter charger to be able to charge a battery. So just trying to clarify this. In case this isn't clear, we can of course revisit it during the question and answers. So to continue, the Fronius have actually is a mainstay in PV inverters or grid-tied inverters. And but because of demands and feedback we've gotten from installers and customers alike, we decided to delve into the residential solution with a hybrid inverter. And here you have that this inverter, of course, is battery connectable. And in this case, you can see that it has one single input, battery input with ampacity of 22 amps. Now, the three-phase inverter, it comes in two power classes, power class ranges. So the first power class range is 3 to 5 kilowatts with 2 MPPTs and with equal capacity. And then the second range is the 6 to 10 kilowatts range. In this case, yes, it has 2 MPPTs, but the first MPPT is 25 amps, has 25 amps current carrying capacity, as against 12.5 for the second MPPT. Now, the major difference between the first class range and the second class range is that for the first class range, only PV point is possible. But for the second class range, with PV point full backup possible. I will be explaining PV points in the subsequent slides. So to make things easy, the Gen 24 inverter has actually been designed with the installer in mind, such that at the end of the day, what you need for proper installation would not exceed a Tox 20 screwdriver, and then of course your quick start guide, and then updating it or uploading Fronius SolarWeb. Now, Fronius SolarWeb is our online database where you are recommended to upload your inverter once installation is done, so that you can conveniently monitor your system from wherever you are in the world. Yeah, of course, via the internet, using your monitoring device. It could be a smart laptop or tablet. Okay, so let's now have a brief look at some of characteristics of in terms of installation. It can be installed both indoor and out. For ambient temperature figures, it ranges from -40 for the Primo, -25 for the Simo, up Celsius, respectively. It has 0 to 100% permitted humidity. And in terms of altitude, the Primos can be installed up to an altitude of 4,000 meters level. And then for the Simos, it can be installed up to 3,000 meters above sea level. So to buttress on that, this is exactly what. So for installations, like I've said, it can be installed both indoors and outdoors, but we recommend that it be installed under shade. This, of course, helps the ambient temperature coefficient, because generally, for inverters installed outdoors, if temperature increases beyond some certain limits, it will eventually affect, say, their optimal performance. But the good thing is that our inverters can actually perform even at 50 degrees Celsius ambient temperature, thereby outperforming most inverters in the market. And of course, having said that, I must say here that the all Fronius products are actually tier 1 products. We have recommendations that should be adhered to. Yeah, so installation directly under sunlight, this is possible, but then it's going to, at some point, if the ambient temperature exceeds 50 degrees Celsius, derating will occur. Derating simply means instead of overheating or over-laboring the power electronics inside the inverter automatically cuts down its power production to some certain level, so as not to overwork the power electronics. That is in the event of the ambient temperature exceeding 50 degrees Celsius. For other products, you have this happening even at 35 degrees Celsius ambient temperature. Okay, so these are the other conditions that we advise our products not to be installed under. Animal dung tends to contain ammonia, and these are very toxic materials, so we advise that they are not installed in farmhouses. And because of the noise or the noise that the fan makes, we advise it not be installed in the living room. The garage, of course, could be a hallway, could be a good installation site for the inverter. Greenhouses, of course, enclosed area, enclosed spaces where, of course, you would have increased ambient temperature. Therefore, it's not advised to install inverters there. And of course, industrial areas, you have exposure to ammonia or other toxic gases, substances, please, it's advised that our inverters are not installed in these areas. So all these are also, of course, enclosed in our quick start guide, and this will enable you to perform a good installation of the inverter. In terms of clearance, we recommend 193 millimeter or 19.3 centimeters from the top, and then 22.5 centimeters from the side. If you're going to install multiple inverters, ensure that you have a space of 17 centimeters in between the inverters. And of course, 30 centimeters from any object on the ground. Good. So what makes our inverter thick? One of the main reasons is because it's ruggedly designed, and then its cooling, the cooling technology we employ is the active cooling technology. So this makes it possible to suck in relatively cold air from around from the surrounding, and then eject um, the hot air from the power electronics via the cooling fins, as you can see as you can see from the illustrations here below. So basically, for installations, you usually have a wall mount you would have to install first of all before installing the inverter. The direction of installation for the wall mount bracket is already indicated. So all you need to do is to now install the wall mount bracket and then snap in the inverter, and then of course put in the cover. So once the cover is placed, you can now turn on the switch and then your inverter is on. Great, so that's for general installation. We're now going to go through the cabling. So with the cabling, we're going to have an in-depth look at how this the installers are the installation is done with respect to cabling, both on the DC and on the AC side. So to make things much easier for installers or for installation, we, unlike what we have previous inverters, that is the snap inverters, we now have 180 degrees quick locking screws. So this means if you turn this quick lock screws 180 degrees clockwise, it will lock. And then if you turn it counterclockwise, it will unlock. So this makes it pretty easy for installation. So meaning that you don't have to screw endlessly to unscrew or to screw down the screw during installation. So yeah, basically, you have 2 of these screws on the inverter cover, and then 5 of them on the DATCOM cover. So this black covering here is what we call the DATCOM cover. DATCOM basically is the data communication, and then this covering is what covers the DATCOM area. So by the time you unscrew these 5 screws using your Torx 20 screwdriver, you're going to now have access to the cabling area, as you can see. So in the middle here is the pilot, or preferably called the data communication card, through which is possible to communicate with the inverter. So it is there that we actually derive the name for the cover that I was talking about earlier. So then with it, with the cover off, you can also have access to the DC connection points, as you can see labeled here, DC. And then we have the AC point here. We also have some an indication here, OP. The OP here stands for opportunity power, or PV point, as I have earlier stated, and we'll be addressing it later on. So to start with, for the DC side, here you can connect your module. That's your solar panels. You can connect them to this point. That is the positive terminals. And then this other part is for the negative terminals. Here, like I said earlier, is your data communication card. There you can connect your communication cables. And of course, here is your mode bus RTU port with which you can successfully perform energy management. I will be explaining that later on. And then we now come to the AC side. Of course, when DC comes in, what you should be expecting is AC. So here you're going to have your AC connection terminal, your live, neutral, and earth. Obviously, this is for a primal inverter or a single phase inverter. If it were a three-phase inverter, you would have five terminals here: line 1, line 2, line 3, and then neutral and ground. The port here, the terminal here is for PV point. So just for summary, the PV point is a point where you can actually have power generated for you, for your use, even without battery. So long as there is irradiation from the sun, you can of course get power supply supplied on this terminal using our Gen 24 Plus inverter. So I'm going to be, like I said, talking more on that subsequently. Great. So these are just basically the dimensions of our connection points and terminals. Yeah, same thing here. Of course, also the same thing here. But then what I would like to stress on here is that for once you're connecting your communication cable, please ensure that you pop out only opening meant for a particular communication cable that you want to connect. Ensure that you don't pop out more than necessary because it will reduce the IP protection of the inverter if you do so. So meaning that if you just need two communication cable to be connected, just pop out two as indicated here and then connect. If you pop out more than necessary, you make it possible for ingress of dust or water particles. Like I said, the inverter, I don't know if I've mentioned this earlier, the inverter is IP66 protected, meaning that even if installed even under the rain, the water particles will not penetrate into this inverter. So that is what the IP66 is actually meant. So bringing us back to this point, it's very, very important that you ensure that you play your own part in ensuring that the inverter maintains its IP protection level. Okay, so in addition to this, we have what we call SPDs. SPDs are simply surge protection devices. So surge protection devices are installed in order to protect the inverter from surges emanating from, say, overvoltage and lightning. And they are normally connected in between the solar module and the terminal of the inverter. So they usually arrive ex factory, meaning that it is optional. So there are some regions that are not too, say, exposed to such faults like lightning, but then some are. But in order to ensure that your products are protected, it is also recommended that you order the SPDs for DC side protection. So mind you, this is basically for DC side protection. Okay. Yeah, so this is basically in continuation of the completion of the installation. Once you have your cables connected, next thing to do is to mount your DATCOM cover and then screw all the screws back and then put up your cover, the inverter cover, and then turn the DC switch to the on position. Once that is done, and so long as there is irradiation, you would of course have power being generated to your AC point. Great. So integrated safety devices on our inverter include insulation measurement, RCMU, which is a short name for residual current monitoring unit. It has anti-islanding protection, reverse voltage protection, SPD as initially mentioned, although this is optional, but can be retrofitted. And then of course, we have output power reduction, which is what I meant by derating in the case of high ambient temperature conditions. Good. So in order not to say leave us in the dark per se, I put in this video to see if to have a clearer understanding of the installation of the inverter. So, okay, having a bit of a problem. Okay, let me play it from this point. Great. Good. So this is basically a very short video on the installation of the inverter. As you can see, this is the wall mount bracket. So once the wall mount bracket is mounted, you can now snap in your inverter and then unscrew the DATCOM cover using the 180 degrees. You can see how easy it is, just unscrewing it anti-clockwise and opening it. And like I've explained to you in the previous slides, you can now slide in your voltage, your terminals, cables from the module, and then connect them to the respective terminal on the inverter. We've made connection so easy such that you can actually pull out the connection terminals, pull them out because they are spring clamps. They have spring clamps. You can pull them out and do your installation. So we've made it very modularized and pretty much easy to achieve, as you can see. So once the DC side has been connected, you can now go ahead to the AC side to do or continue the installation. And like I have said earlier, for the primal, which is single phase, it's going to be 3 terminals, L1, neutral, and ground. Then for the 3-phase, it's going to be 5 terminals. That is the 3 phases and neutral, and of course, ground, as you can see. So once that is done, you're pretty much done with the installation. Then you screw back your screws on the DATCOM cover, as you can see, and then snap back your inverter cover, and then turn on your DC disconnector switch, and then you are ready for commissioning. Yeah, so just wanted to impute or put in this video so that we can understand what I have been talking about for, say, in the previous slides. So next up is data communication. So yeah, let's say you have concluded installation, and then next thing is to continue with the commissioning. You cannot have a successful commissioning of the inverter, or commissioning basically is just putting your inverter to work or making it work. As you can see, the inverter does not have any display. So the display basically is going to be your monitoring device. And in order to do so, you'd have to connect your inverter or connect your monitoring device to the inverter or vice versa. In order to do so, you need to communicate with the communication card or the data communication interface, which we preferably call the pilot. So you can do this either via wireless LAN or LAN, via router, and then of course with internet connection, you can now view your inverter or whatever is happening with the inverter on SolarWeb. SolarWeb, like I've mentioned in the early slides, is our online database where you can register your installed device and then remotely monitor your device from wherever you are in the world. There are pretty straightforward steps how this can be done. I will be mentioning them just after I give you a brief of what the pilot is all about. The pilot basically has LED displays, data loggers, web server, and a Wi-Fi card all embedded in one data communication card. So with this, you can achieve visualization via Fronius Solar Web Portal, Fronius Solar Web app, and of course, Solar TV. Um, yeah, so it has a pretty numerous open interfaces. It includes Ethernet, whereby we can communicate via Modbus TCP or Modbus RTU. And of course, we have what we call the WSD function, wired shutdown function, which isn't popularly used across sub-Saharan Africa. And then, of course, we have a digital input and output, a very, very important input and output port that comes in very handy when it comes to energy management. We'll be seeing more of that subsequently. Okay, so like I was saying, we have two Modbus RTU ports through which we can connect a smart meter, that is the Fronius smart meter. The Home Pilot. The Home Pilot is a control device that we use to achieve generation of hot water. That's a whole new topic on its own, but then just to tell you that you can actually connect the Home Pilot there. You can also connect your battery and then do some third-party connection with other non-Fronius products via this interface. So we call it the SunSpec interface. Just to give you a brief of how you can use the inverter to control an external device, say air conditioner, electric car, pool pump. This is basically how it works. So in order to summarize this page, your inverter is programmed via the input-output port. So through this input-output port, we have four programmable input-output ports that are configured as output ports. So once the condition is reached, the condition could be that if you're generating, say, above, say, 2 kilowatts or 3 kilowatts, depending on how your power generation is, this serves as a threshold condition to trigger a 12 volts, an external 12 volts relay. Now the contact of this 12 volts relay now turns on the device located at this point. So this could be your air conditioner. So say if on a very good day, on a very sunny day, that you're generating up to say 3 kilowatts, once you hit that figure, the inverter automatically triggers this relay, and then the switch, the contact of the relay now energizes the heavy appliance, and then this now helps to turn on your AC, for example, and then thereby so doing, you can achieve actual cooling of your room space. So that is just one part of, say, lots and lots of areas on how our inverters can actually be implemented. It's actually a smart inverter that can do various or perform various functions and provide various solutions. For want of time, I might not be able to cover everything. I'm just trying to amass as much information as possible within this short period of time. So just like I was saying, using four here, it's actually 6, but then we have only 4 configurable for now. 2 of these 6 inputs and outputs are dedicated for other control uses. So we have just 4 that are configurable for you to use to intelligently turn on and turn off your pool pump, air conditioner, charging stations, heat pumps, and the likes. Good. So this is how the data communication card or the pilot looks like when turned over. So you have your LAN ports, as you can see, You have your USB ports, which is normally used for power supply only, and then you have your LED status display. Yeah, so to activate this inverter, because it doesn't have any display, but right in between the two LEDs, there is a touch sensitive button that is used to activate the Wi-Fi access point. So once you tap this button once, the Wi-Fi access point automatically is open. So you can, of course, connect your inverter using this Wi-Fi access point that is just that you have been opened and connected to your monitoring device or your commissioning device, which could either be your smartphone, tablet, or your PC. So just to buttress more on that, this is how it looks like. One quick tap opens the Wi-Fi access point. Two quick taps opens the WPS function, especially for those internet gateways that use a router. So if you're using a router, this makes it faster to connect your inverter to. And then one long push usually deactivates this touch sensitive button. Conversely, so if you press it for long, for 3 to 6 seconds, it deactivates it. If you repeat the same process, it will reactivate the touch sensitive button. Yeah, there are 3 major ways we can do the commissioning of the inverter. We can use the app via the newly launched app that's available both on iOS and Android stores. It's called the Fronius Solar Start. So once you download, it's free to download. Once downloaded, you can open it and then use it to commission the inverter. The connection is automatic once you tap on the touch sensitive button. So this can be done via the smartphone and of course via a web browser. So for the web browser, you still need to open the Wi-Fi access point, and then on your web browser, preferably Google Chrome, once you enter this IP address, it will automatically link you up with the commissioning wizard. And then from there, you can go ahead and do your commissioning. Yeah, the other way you can achieve this is via okay, this is for the web browser. Yeah, okay, it's just explaining what it's the processes involved. This might be too technical, but then it's quite straightforward. Open the Wi-Fi access point, locate the Fronius inverter, log on to the Wi-Fi of the inverter, use this password, and then on the web browser, impute this IP address. Once that is done, it will automatically take you to the installation wizard where you can now continue with your commissioning process. So basically the commissioning process is 3 steps. The network connection, which is the first step, of course, it will connect the inverter to the network. And then the next step is to set up your product or set up the inverter. There you'll have to impute the inverter specification. And then lastly, you would now have to upload the inverter onto the internet via SolarWeb. And once that is done, you have successfully commissioned the inverter. It's quite straightforward. So that was via web browser. This can also be done via LAN. In this case, you don't need a password. You just need a cable connection from LAN 1 to your commissioning device. And then this time around, this is the IP address you'll need to use. And then once that is done, you'll have to go through the 3 major or 3 steps. That is network connection, product setup, and then SolarWeb connection. It's quite straightforward. Good. So, like I said, I would these adaptations I made just to add to this presentation. We can achieve solutions that including generation of hot water which is included in the thermal storage solution provided by inverter. Of course, you can achieve battery storage. And here I must say that our battery storage solution comes in with the BYD battery premium battery box, HVS and HVM. So for now, we are compatible only with the BYD premium battery box, HVS and HVM. It employs a lithium iron phosphate cell chemistry, and of course ensures easy commissioning. I will be, yeah, I think I have some slides that says more about the battery storage. And then PV Point, like I said earlier, gives you or provides a basic power backup function. And this is integrated at standard. You don't need to do any other extra connections for it. With this, you get up to 3 kilowatt single phase power, even without a battery connection. So, like I said, this is the BYD combination matrix. So for the connecting BYD batteries to Fronius inverters, say the Fronius Primal, that is the single phase inverter, you can have 5.1 kilowatt hour to 7.7 kilowatt hour connections to it. And then for the three phases, you can have from 5.1 up to 10.2 kilowatt hour connection for the storage solution. And then on, that is for the HVS. Now for the HVM, you can have from 11 up to 19.3 kilowatt hour possible storage solution. And then you can also, that is for the HVS, HVM with the Gen 24 Primal, that is single phase. Now for the three phase, you can have it from 11 to 22.1 kilowatt hour. In case you don't understand these figures, I think I have some slides that will explain it. Yeah. So as you can see, this explains what I was talking about earlier. So the BYD battery boxes comes in modules. They come in two variants, the HVS and HVM. HVS stands for high voltage small, and then HVM stands for high voltage medium. Now, the high voltage small, or HVS, comes with a control or nominal voltage of about 100 volts, while the HVM comes with a nominal voltage, nominal control voltage of about 50 volts. So it's a high voltage device. So also is the inverter. So the HVS has a minimum module compatibility of 2. So meaning that one module has an energy storage capacity of 2.56 kilowatt hour. So meaning that in order to use the least combinable module, least combination you can have is 2 over the 2.56 modules, which gives you 5.1. And then from there, you can go as high as 5 of it. And then apart from that, you can actually have a parallel of this 12.8 kilowatt hour towers, as you can see in this case. That is for the HVS. For the HVM, same thing is possible. The minimum module combination is 3 of 2.57 kilowatt hour, and that can be stacked up to 8 of them for one tower. And then, as you can see, 3 towers can actually be connected in parallel to give you up to about 64.3 kilowatt hour storage capacity. Good. So how do we come about these figures? I just chipped in this slide just to do a bit of an explanation. Of course, we know that power is equals to voltage times current. Like I earlier said, or earlier pointed out in the earlier slides, current carrying capacity of inverters are 22 amps. And then you have the nominal voltage of the HVS to be 100 volts, as earlier said, and the HVM is 50 volts. So if you have, in this case, two modules of HVS, which come in a nominal voltage of about 100 volts. So this gives you up to about 200 volts. And then if you have 4 of them, it will give you up to 400 volts, or exactly 409.6 volts. Okay, so that is 100 times 4. And from the previous slide, I told you can have up to 8 stacks of the HVM module. These are 50 volts rated. So 50 times 8 gives you approximately 400. So it will give you exactly 409.6 volts also, same as the here 10 points for the HVS 10.2. So that's how these figures actually come about. And then by the time you multiply, say 409 volts times 22 amps obtainable for the Primo 3 to 6 and Simo 6 to 10 kilowatt ranges, you are going to be getting 9 kilowatts of power. So that is actually a very remarkable figure, because there are very, very few products that can actually give you this power for charging and discharging of inverters in the market. So for the HVS and HVM, you can get up to 9 kilowatts, both charging and discharging power with the Fronius inverter. Okay, so to give you a brief look of how full backup is done. So once there is grid outage, as you can see, of course, the backup switch turns off so as to isolate the grid point from the inverter. The inverter now gets the power from the solar generator or from your module, then charges the battery, and of course at the same time provides power to your load point. And then of course, in the event of low irradiation or at nighttime, you can of course get power to your load point using via the battery. So that's basically how the full backup works. And then the PV point, as I've earlier mentioned, you can get up to 3 kilowatts of single phase power. This power can actually shoot up to 4.1, but that can last for only 5 minutes to give enough room for appliances that have high starting current. So for the PV point, this is how it works. In the event of no grid, of course, the PV point takes power from the sun and then provides that particular PV point socket. So this means that you would have to connect, say, your appliances to this PV point to be able to enjoy the benefit of the PV point power supply. Good. So I'm coming to the end of the presentation. I hope I haven't I hope I'm not too fast. So this, like I earlier said, our inverter, the hybrid inverter doesn't come with a display, but we ensured that with the LED status, you can use it to explain or give you details of what the inverter is actually going through or what state the inverter is. So this, I decided to add this just to give you an idea of what this LED status or what the display are all talking about. So this is basically for installers. If there's any service case or any error code, it will come as a 4-digit code. And then this code comes in with a brief explanation of what the code is all about. And then of course, there is another app we use. We call it the Fronius SOS tool. With that, you can be able to decode what the code is all about. But usually it comes in self-explanatory to your dashboard. So once it comes to your dashboard, you can just read it. It tells you exactly what the inverter is saying. It could be push messages to tell you that, okay, your inverter hasn't been working, or there hasn't been DC supply for over 24 hours, meaning that, okay, there could be, say, maybe some serious shade over the solar panels, which is causing the low DC voltage, or maybe through any other cause. I'm just giving us an example of what might prompt some service messages to your display. And then finally, it is possible to do updates on the inverter. So once updates are available, it will pop up. All you need to do is to click on the update icon, and then your inverter will be automatically updated. Yeah, so like I said, I didn't want to go beyond 45 minutes, and I did my best to compress as much information into these slides that I've presented. So, of course, as earlier mentioned, there will be time for question and answer. I will, of course, do my best to answer questions during this period. Yeah, so that's
Thank you so much, Engineer Cyprian. Thank you very much. That was quite an in-depth look into the inverter. I see here that there are no questions that have been typed, but does anybody here on the call have any question? Because I have a few that I want to ask, but let me just throw it out for our listeners. Anybody with a question?
I hope it wasn't too technical.
I thought it was appropriate. Some of us are at that level.
Okay, great.
Okay, we have a question. Engineer Paul, if you are in a place that is too noisy, you can type it as well. Charles, you can talk.
All right, good evening, everyone. Thank you very much for the wonderful presentation. There was a place that actually caught my attention. The place where you get your power from grid, from the PV, and then from the battery. So when there is no grid, there's a cutoff to automatically get your power from the PV. And when the PV is not generating quite enough, you get from your batteries. Okay. But where my question is coming from is, I quite understand that concept, but I'm pretty much very aware that when there is PV that is enough, there is grid on ground at that time as well, and there's enough on the battery. Is there a way this connection is run on the Fronius system such that it is not your battery that feeds the load? Because I've seen a situation whereby even if there's PV coming in and there's grid coming in, it still takes from the battery.
Okay, yeah. So it doesn't happen this way for our inverters, but I must say also that for the situation that you've experienced this, I believe it has to do with some settings. Once there is grid, and then you also have storage battery, your load point is not supposed to take power from your battery. It's supposed to kick in once there's an absence of grid. So that's how it's supposed to be.
Sorry, and yes, you were breaking up.
Hello?
I heard you clearly. I heard you clearly.
Okay, can I continue? Yeah, I was actually in the process of explaining it. Yeah, so that's basically how the inverter works. So it's actually the inverter has the same, the inverter output and the load point all are connected on the
Engineer Cyprian, you're on mute.
So sorry about that. I don't know how long I've been muted. So like I said, for that particular situation, Charles, you were talking about, it's either that the inverter was configured to function that way, but normally it's not supposed to happen. I believe it's due to some settings. Normally, once there is grid, the grid should supply the load. And then once the grid goes off, then the storage or the battery comes in and then supplies the backup, basically. Yeah.
So I guess that's probably a default on the particular inverter I'm making reference to, because we've tried to actually make corrections on the settings on the inverter, but it still keeps repeating itself. So we just felt like that's its own issue in terms of upgrade that they will need to do on it.
Yeah, it's a peculiar issue with that particular inverter. Yeah. But
Thank you very much.
I'd hear that inverters come, anyway, ours comes with priority level configuration, meaning that you can prioritize what our inverter does with surplus energy. So I'm talking from the perspective of surplus energy now. So say you are producing more than you are consuming, so you already have surplus. So you can prioritize the function of the inverter on what it's going to do with your surplus energy. So we have three priorities: priority 1, priority 2, and 3. And these priorities are actually interchangeable. So we have our own pilot, we have our energy management, and then we have our storage. So if you prioritize storage as priority 1, once you have surplus, it will ensure that it supplies your storage with surplus energy. Once your battery is now full, it will now go to the next priority. If it is energy management, it will now engage it. So for energy management, it could be triggering of heavier loads or heavy loads like I've mentioned earlier, your air conditioners, EVs, and the rest. Then the third priority will now be generation of hot water. All these are very special topics, and but then I just wanted to add this as an extra information. Yeah.
Thank you, engineer. Okay, we have a question from Salim, and he's asking that about the commissioning of the inverter. He guesses that a single app can be used to commission several inverters.
Yes.
Is that accurate?
Yes, a single app can be used to commission several inverters, yeah. So you could have several inverters in a site per se. So you can use this particular app, that is the Solar Start app, to commission these inverters on site, yes.
Okay. Engineer Paul asked, what are the price ranges for the inverters?
I don't actually deal with pricing per se. That's not my jurisdiction. And but then I can give you an idea for this purpose. But I must say here that normally how we operate is that I'm on ground as a Fronius technical staff. So I offer both pre-sales and after-sales technical support. But then in terms of sales, we actually do that via our country-based distributor. So they are the ones that normally issue these prices. Okay, what will happen is I have a comprehensive price list that I can send as a file to you so that you can now share it to the attendees. I think that will do, right?
All right, engineer, there's a question here. In terms of monitoring and measurement, what does the what can the inverter give you? in terms of what parameters are measurable?
Okay. I can say every conceivable electrical parameters, be it apparent power, real power, phase difference, power factor, voltages, you name it. So these are all captured. These are all capturable. I don't know if we have the time. I was thinking of just giving us an example of what it could be, but then it might just take us into another stage of discussion. Yeah. So, but every conceivable electrical specification or characteristic can be measured and monitored. Yes. Summarily speaking, yes.
Just two more questions. This question is about the anti-sliding protection. If it fails, is there any backup to that?
If it fails, yeah, the inverter has an inbuilt anti-sliding protection. And of course, as you can see here, I believe my screen is still showing, yes. There's also what we call an Enwitech box. This also adds, this is basically the first point of protection. And then, of course, it has another backup protection inbuilt or integrated inside the inverter.
But isn't that switch normally closed?
Yeah, it's normally, sorry, there's supposed to be an animation here actually to close once the grid is available. Once the grid is not available, as you can see now, it opens so that it isolates this AC point, this AC load point, and then now supplies the load via the battery. So yeah, it's there's supposed to be an animation here to close switch once the grid is on. Yeah.
Okay. And the last question is in terms of the is a direct load control ability for the inverter.
Sorry?
So does the control where you talked about probably if it does if there's a threshold of voltage that is reached, then it can activate, let's say, the AC.
Okay. Let me try and get to this.
Yes. So does it do that only based on a threshold voltage? Can you program it to do it based on like time periods?
Yes, you can. You can. There are actually two ways you can do that: time-based or surplus or threshold-based. Yes.
Okay. Fantastic.
Yes.
Someone is asking, could we have this file, PDF or PowerPoint, to go through later more thoroughly?
Sure. I will do the presentation.
Okay, all right.
So
thank you very much, engineer.
And price lists, yeah.
Okay, all right. So once engineer Cyprian sends it to me, I can share it with all of you. Again, we want to thank engineer Cyprian Okolo of Fronius for really giving us an in-depth analysis of the hybrid inverter with wonderful slides that really captured what he was saying. Engineer Cyprian, we really appreciate your time. And on behalf of ETC, we want to thank you as well.
Yeah, thank you very much for having me. It was quite a privilege to share my little experience with you. And of course, I'll always, be, in case you think of any questions or you have any inquiry to make, I will leave my email address so that I can reach out, and then of course I'll do my best to answer, get answers to inquiries. Yeah. So thanks once again for having me. It was quite a privilege.
Thank you very much. So everybody, thank you for coming. Usually the plan is to have this probably once a month, but as it stands now, we may have one quickly before the end of the month because our resource person may not be around in the country to do it. So he wants to do it before he leaves. So I'll reach out to all of you on that. But thank you very much, and everyone enjoy your night.